Okay, for complex roots, I am going to refer you to the key for number 11 for the box method, but I am going to once again show you the other method where you can say a plus bi and a minus bi. So if you call this thing a and this part bi, then you have a plus and a minus, and that will give you a squared minus bi squared. So you can do x plus 3 quantity squared minus 2i squared. So x plus 3 quantity squared gives me x squared plus 6x plus 9. And the 2i squared gives me 2 times negative 1. Oh, sorry, no, 4 times negative 1. Be careful. So it's 4i squared, which is 4 times negative 1, which is negative 4, but I have this minus sign right here. So that actually gives me x squared plus 6x plus 9 plus 4, so plus 13. Again, you can use the box method if you'd rather to multiply or just distribute each term of the first parentheses into each term of the second parentheses. This is just a little shortcut from another teacher. Okay, so when you are given a problem like number 12 and number 13, it will say write all the roots and then write the polynomial in factored form. So the first part is finding all the zeros or all the roots, and the second part is writing the polynomial in factored form with real coefficients. And then it also says whatever came from Desmos, it says from Desmos, show, draw, and label a sketch. So to find the zeros, firstly, I have negative 3i, that means I'm going to have positive 3i. And then if I want to go to Desmos and graph this, I will just type this in and x to the third minus 4x squared plus 9x minus 36. You will double check that you have no typos in your Desmos graph. That is the thing that makes people get this wrong most. And we can see that the graph just goes through 4, 0. So that means that I have a real root at positive 4. And so I will also draw the little graph to show that I have a real root. The graph is doing one of these, and I have a real root at positive 4. The degree is 3, so I should have 3 roots total. And I have 1, 2, 3, so that works. All right, so now I need to write my factors. So I have x equals, just zoom in here a little. I have x equals negative 3i and x equals 3i, and then x equals 4. So I will use my roots to then find my factors. So remember, to find your factors, you want to get everything on one side equals 0, and that will give you your factors. So I want to do plus 3i plus 3i, and then minus 3i minus 3i. That gives me x plus 3i equals 0, and x minus 3i equals 0. And then for this last one, I will subtract 4 on both sides, and I will have the real root of x minus 4. Okay, so then remember that when we are writing our polynomial here, we know we have that x minus 4, but we cannot have any real coefficients. So our factors that have the I in them, we need to multiply to get the i's to go away. And so they should go away when we multiply because they are complex conjugate roots. They will make factors that multiply to give me only real coefficients. So x plus 3i and x minus 3i. And of course, you can use the shortcut that I showed you in the problem above as well, for what you know about a difference of two squares, which is really what this is. And so I have those add up to 0, and this guy is -9 times -1 because I squared is -1. So that's +9. And so these two multiply to x squared plus 9. And then I do have the rest of my polynomial. And so the y equals also is needed to write a polynomial function. You need that y equals. All right, and so number 13 is a little more complicated because the 5 minus I and the 5 plus I are a little bit more complicated to deal with, but I also will need to put this into Desmos. So let's get our Desmos back. And we have f of x equals 2x to the fourth minus 25x plus 99. Oh, sorry, 25x to the third plus 99x squared minus 100x and minus 78. All right, so we can see that we actually have two real roots here, which is what I expected because it's a degree 4. So -0.5 or -1/2 and 3. All right, so I'm going to, again, whoops, sorry about that. I'm going to draw the picture to the side to show how I got my real roots. And so I know that this goes through -1/2 and I have already forgotten -1/2 and 3. So it goes through -1/2 and 3. And so those are my extra roots here, my real roots, I should say. And so again, I knew that I was going to have 4 roots total. So since I had 2 complex roots, then I have 2 real roots. Okay, so I'm going to have my x equals 5 minus I for one complex root and x equals 5 plus I for the other one. And then for my real roots, I have x equals -1/2, and then I have x equals 3. I want you to notice that this starts with a 2. So my leading term is a 2x to the fourth. So one of my factors needs to have a 2x in it. And this fraction is what's going to give us that 2 because I need to multiply both sides by 2 to get everything on one side because I don't want to have a decimal or fraction in my factor. And so I end up with a factor of 2x plus 1. And then my other real factor, or factor from my real root, is x minus 3. And then for my complex factors, I'm going to subtract 5, subtract I, and then subtract 5 and add I. So x minus 5 plus I and x minus 5 minus I. And I already know that I'm going to have to multiply those two to get my coefficient with real roots. So I'm going to do my box here. Again, if you want to do the shortcut that I showed you in the top problem, you just got to make sure that you show some work to show how you got it. So x minus 5 plus I and x minus 5 minus I. So this can go pretty fast when you are not talking about it and you're just writing it. Just have to be careful with your negative signs. So I have a negative ix and a positive ix, a 5i and a negative 5i, and then my negative I squared is really -1 or +1. So that gives me, when I multiply those, I get x squared minus 10x plus 25 plus 1. So that gives me x squared minus 10x plus 26 for my complex roots, and then 2x plus 1, and then x minus 3. And it does not matter what order you put these in, but you just can't have the i's, so you do have to multiply those. And so that is 7g.